Hello, and welcome to another video in the Azure Cloud Native series. In this session, we'll be covering how you can save costs on low priority workloads with AKS and Azure Spot. The first thing you need to understand is the notion of node pools in AKS. A node pool is a set of agent nodes with common characteristics, typically the VM size and operating system, which under the hood in Azure maps to a virtual machine scale set. The beauty of node pools is that they enable you to add different forms of compute to a single cluster, each of which can be managed and scaled independently, including with autoscale. One of the common best practices for running AKS at scale is to maintain a set of nodes specifically for the system services like core DNS and metric server. AKS has now elevated that idea to a first-class concept with the notion of node pool modes. The first node pool created in the cluster is labeled as a system node pool by default, and it is intended for system services, while later ones are tagged as user node pools by default and are intended for your applications. A nice benefit of this model is that user node pools can be scaled down to 0 nodes and be based on ephemeral compute like Azure Spot. So with that, let's take a look at Azure Spot. As a hyperscale cloud provider, Azure has computing capacity in over 50 regions around the world. Within each of those regions, we offer a number of different types of compute, from general purpose instances to memory or storage optimized VMs to GPU-based machines. At any given time, some portion of that capacity is going unused. With Azure Spot, you can consume that unused capacity at a significant discount, up to 90%, as long as you're willing to deal with lower reliability and no SLA as a result. This trade-off makes Azure Spot best suited to workloads which are not time critical and which are resilient to a short period of interruption. The price of Azure Spot for a given VM series changes periodically based on the demand for that type of compute within the region. As such, you have the opportunity to set a maximum price you're willing to pay for that compute. You can either set a discrete price, in which case your VMs will be evicted if the price rises above that point, or you can set the price to -1, which means that you're willing to go all the way up to the VM's pay-as-you-go price, in which case you will only be evicted if there is no Spot capacity remaining in the region. Now let's take a look at how you can consume Azure Spot in the context of AKS. So I have the suitably named Spot cluster here running in AKS. I'm just going to go ahead and list out its node pools. And you can see that at the moment there's just one node pool in the cluster, and it's the one that was implicitly created when the cluster itself was created, and you can see that it's been tagged as a system node pool. So now what I want to do is add a new node pool to the cluster, a user node pool that will be based on Azure Spot. So the CLI now has this priority switch that I can set, and there's two options for it, either regular, which is the default, or Spot. So I'll set that to Spot. And then I have the option to set a max price, which is what we just discussed. Now you might be wondering, how do I get a sense for what price I should set here, what the current value of this VM type in this region is, and that information is available from the Azure pricing page. So if I look here at Linux virtual machines in WestUS 2, I can see that the D2S v3 series, which is the default for AKS, if you don't specify the VM size, that's what you'll get. The pay-as-you-go price is currently listed at roughly 9.5 cents an hour. But if you look over here at the Spot price, it's currently at about 1.5 cents an hour. So pretty dramatic savings available. Now again, that price may change, and it does change periodically based on the demand for that particular VM family within the region. And so you have the ability to set a price that's higher than that current price if you want to have some amount of buffer for being able to still get capacity before your VMs get evicted. So in this case, I'm going to go ahead and set the max price a little bit higher, say to 2.5 cents. This is still a dramatic savings on the pay-as-you-go price, but giving me a little bit of buffer should that price increase. Now, another common best practice when using Spot node pools is to leverage the cluster autoscaler. And the reason for that is if the nodes happen to get evicted as a result of price changes, the cluster autoscaler can kick in and attempt to re-provision a new node potentially at a slightly higher price. So I'm going to enable the cluster autoscaler here, and I will set the min and max count for that. And that's going to go ahead and provision on an additional node pool into my cluster. That'll take a few minutes. Okay, so that provisioning has now completed, which means that if I rerun this list command, I should see my 2 node pools. And indeed, there is the second one, which has been marked as a user node pool. If I list out all of my nodes, you'll see that there are 3 that are part of the system nodes pool, as well as 3 new ones from the Spot node pool. By default, Kubernetes would consider all of these nodes as candidates for scheduling a workload, so we mark the nodes in a couple of ways to make sure that only the types of workloads that should land on Spot actually do. You can see those 2 markings by describing the node. The first is a label for scale set priority, which in this case is set to Spot. This allows you to specifically target a Spot node pool for a workload that is suited to it. Second is a taint, which is designed to keep pods off a node unless they have specifically indicated that they are okay with the implications, in this case, the potential for eviction. Now let's look at how we can schedule a workload onto Spot instances. For this demo, we'll use a deployment of Folding at Home, a distributed computing project designed to harness unused computing power from thousands of machines worldwide to run simulations of protein dynamics in service of finding cures for diseases. The community has built out a Kubernetes deployment for Folding at Home, specifically targeted at COVID-19, so that's what we'll deploy. Now, just as there are 2 markings on the Spot node, there are 2 changes that I'll make to the pod spec. The first is to tolerate the taint that we saw earlier, meaning that the pod could run on the Spot instance. In this case, I will also add a node selector that will match the Spot label, which ensures that the pods will only run on Spot instances. So now I'll go ahead and deploy that. And if I query the pods now, I'll see that indeed my pods are running on those Spot instances that I created. So that was a quick look at how you can leverage Azure for Spot node pools to run low priority workloads at significant discounts.